Alrighty, I double checked and those are all good. Sorry for the break in the recording. I accidentally stopped the recording. Okay. So what do we got here? Tacoma has the most votes. So Tacoma would win this election using the approval method. All right. That's interesting. Okay. Oh, here's another example. Let's do this one. The marketing committee at a company decides to vote on a new company logo. Their results are tallied below using approval voting. Okay, which logo wins? So we got 3 logos, A, B, C. Okay, so let's see. A gets 8 plus 7 approval votes. That's 15. B gets 8 plus 6 plus 3 approval votes. That is 9 plus 8, which is 17. And C gets 7 plus 6 plus 3 approval votes, which is 16. Okay, so it looks like B would be the winner here. Whatever logo is marked B would be the winner there. Okay, so those are examples of how to apply each of these methods. Now, if you read the book, when you read the book, because of course you read the book, the fairness criteria are introduced with the examples, and each method is sort of talked about in reference to the fairness criteria. So here are the fairness criteria that, let's see, can I show them all at one time? I believe I can. That are talked about here, right? So if you remember, the fairness criteria are basically ideas that we think a voting method should, should have within the method in order for it to be quote unquote fair, right? So what does it say here? The fairness criteria are statements that seem like they should be true in a fair election, right? So there are, if you've read the book already, you know let's see, there are 4 of them. That's right? Because that's, can I scroll properly? Yeah. There are 4 of them. So there's the Condorcet criterion, interesting word, Condorcet, monotonicity, majority, and the independence of irrelevant alternatives, or IIA. I'm actually going to start with the majority criterion, just because it seems like the, I don't know, like the most basic to me, right? And the majority criterion is basically saying if some candidate choice, right, option has a majority of first place votes, then that candidate should be the winner. Okay, so when you read the book, you see that the board account method and approval voting method can actually violate this criteria, right? Criterion. So criteria is plural, criterion is singular. I might not always get that right, but so it's interesting that like some of the voting methods preserve this majority criterion, right? That always, it will be the case. Whoever gets the majority first place votes will win, but not all methods actually do. Like they saw the board account and the approval voting can actually violate that. And I think we're going to do some examples after right now. To see maybe some of this in action. This is all about Condorcet. Ooh, that's interesting. Okay. Now maybe I won't do any examples, but you will find them in the book. They'll show you like how they'll show you a process, and then you can see how it violates one of the criteria. Okay, so that's majority criterion. Let's just talk about this one, the monotonicity. That is a funny word, monotonicity. Monotonic would be the verb form, I think. So let's see what it says. If voters change their votes to increase the preference for a candidate, it should not harm that candidate's chances of winning. Okay, so this word monotonicity, it's got to be some mathematician who came up with this, because a lot of times in mathematics, like if a function is monotonic, then like an increase in the independent variable always represents an increase in the dependent variable, right? If it's monotonically increasing. So I think they're saying here that like if the number of votes goes up, then it should not be the case that the person with those votes could go from winning to losing, right? That should not happen. Like, getting more votes should not cause you to lose the election. So with this criterion, the instant runoff method can violate it. So what they're saying is, like, if someone is eliminated and you get their votes, then that could actually change your chances of winning. So that's called the monotonicity criterion. Fancy word. Maybe we could call it the more votes criterion. All right. That sort of reminds me of the independence of irrelevant alternatives. Because let's see, if a non-winning choice, so now I'm down here, I'm looking at this one. If a non-winning choice is removed from the ballot, it should not change the winner. Okay. So equivalently, if choice A is preferred over choice B, introducing and removing choice C should not cause B to prefer. So they're saying, right, if you have this, if A is preferred over B and you remove some irrelevant alternative, so like C is not even in our conversation when we're talking about A, B, but if you remove C somehow and suddenly the preference between A and B is switched, then that would violate the independence of irrelevant alternatives, because it's showing that it's actually not independent, right? That even though C is irrelevant to A and B, it's not independent, because removing it, if it switches it, then it's not independent. It actually has some effect. And apparently the Copeland's method, which is also called pairwise comparison, can violate this criterion. That's interesting. See your book for how that's done. And then the top one, Condorcet. So let's see. So first of all, we have to, I think they define the word Condorcet. So the Condorcet candidate, the Condorcet winner, is defined to be the one that is preferred. And it's not always the case that there is one, but if there is a choice that is preferred in every one-to-one comparison, so we're talking about, again, those pairwise comparisons, then that person is called the Condorcet candidate. It's a fancy word. I don't know where that word comes from. And the Condorcet criterion is saying if there is a Condorcet candidate, then they should be the winner, right? So if you're doing a pairwise comparison and there's one option that wins every single time, it seems like it's only fair that that person would be the winner. However, the plurality method and the instant runoff method can actually violate that criteria, where you could have someone who would win in a head-to-head comparison with everyone else, but ends up not being the winner of the election. Obviously, that can only work if you're not doing pairwise comparison, right? If you're doing Copeland's method, that automatically guarantees that the Condorcet would win, but other methods might not. Okay, so make sure you understand what all of those mean. But since we haven't done any examples of what showing like how you would find the Condorcet candidate or what it is, let's do a couple of examples with that. Condorcet. It's kind of a neat word. All right, so example 12. These candidates, okay, here we go. These are the same example we've been doing. We've got the county executive with Goings, McCarthy, and Bunny. We've got the same voting preference or voting schedule. Now they want to see in the election form above, what is the Condorcet winner? So remember, the Condorcet winner would be someone who wins on every head-to-head comparison or every pairwise comparison. Now, the thing is, didn't we already do these pairwise comparisons in another example? Okay, yes, I have found it. This is the example we did when we did the Copeland's method. So the pairwise comparison method. And now, of course, in the Copeland's method, you assign points depending on whether the person wins in the pairwise comparison. But to find the Condorcet, we don't need that. We just need to know who's preferred over who. So let's see, we did our 3 comparisons here. And we found, right, that McCarthy is preferred over Goings in that pairwise comparison. Here Goings was preferred and here McCarthy was preferred. Okay, so I'm gonna remember that. So we had 2 M's and a G. Okay, let's go back to what we're doing now. So in order to find the Condorcet winner, we have to have all the pairwise comparisons, just like we did before. So we would have, right, G versus M, G versus B, and M versus B, right? And we found that McCarthy was preferred here, McCarthy was preferred here, and was it G that was preferred? Dang it. Now I can't remember. Yeah. I tried to remember, I couldn't remember. All right. Okay, so then the question is there a Condorcet winner here? Well, the Condorcet winner would be the winner who won every single one of its pairwise comparisons. So we only have 3 options, so there was not that much going on, but here are the two. These two are where M was compared with the other candidates. And yes, indeed, McCarthy won in each of the pairwise comparisons that he was in. So McCarthy is the Condorcet winner in this case. Right. Notice how like this one is not really counted because that is not one of the pairwise comparisons where McCarthy where McCarthy was compared. So you don't have to one person can't win them all because there are some comparisons they're not involved in. But you're looking at every time you do a comparison with a candidate, if that candidate wins in every single one of their comparisons, then they're the Condorcet. So McCarthy is the Condorcet winner because McCarthy won every single one of his pairwise comparisons. Want me to write that down? I'm just going to use he. Okay. All right. Now, of course, this question was a little bit leading. It said in the election form above, what is the Condorcet winner? Now, if it asks it like that, you kind of like assume that there is one because of the way they ask it. Compare that with example 13 here, where it says, does this voting system have a Condorcet candidate? And if so, find it. So here it's possible that maybe there is no Condorcet candidate, right? That would be someone who does win all of their pairwise comparisons. So maybe they don't. So let's see. So we've only got 3 options. ABC. And again, we know that if we have 3 options, there are 3 pairwise comparisons. So we can compare A versus B, we can compare A versus C, and we can compare B versus C. Okay. And remember, this is not Copeland's method, so we don't need to assign points. We just have to see who wins, who's preferred over the other in a pairwise comparison. Okay, so let's see. Let's look. A versus B. So here A is above B. Oh, but look, A is above B with those 14 votes. Okay, so we've only got, so A has 14 votes where it's preferred, but B is preferred these 2 times, so that's 17. Okay, so A versus B, A is preferred over B with 14 votes, but B is preferred over A with 17. So in this case, B is preferred. So B wins that pairwise comparison. Okay, what about A versus C? Let's see, A is above C here and only there. Okay, so that means that A is preferred over C in those 14 votes. And then, so that means that C is preferred over A in these 2. So that's also 17. Okay, so again, in this one, C wins this pairwise comparison because it has more. All right, and finally, B versus C. Let's see, B is above C here and here. So B gets those 16 votes compared to C, who's above B with 15. Oops, again, trying to write with that friggin' highlighter. Okay. All right, so who's here? So B. So yes, there is a Condorcet candidate, and it's B, because in every comparison involving B, B wins. Does that make sense? Okay. So yes, B is the Condorcet. I notice that it's capitalized. It's like a name, Condorcet. Candidate. Okay, so remember that a voting system or a certain preference schedule does not have to have a Condorcet candidate. It could not have one at all. It could be the fact that there is no one option that wins in every pairwise comparison they're involved in. In these two cases, there was one. Okay, so now we know what a Condorcet candidate is and what the Condorcet winner would be if there were one, and how to find it. Okay, now if you could, let's go back to the fairness criteria. So we saw that the methods that we've talked about, right? Some methods violated some of these criteria, right? So you might ask, like, well, is there a voting method that actually meets them all? Is there a voting method that, such that if the person with the majority of first place votes will win, that if somebody gets more votes, then it does not harm their chance of winning, that if some irrelevant alternative is removed, that it won't affect the preference, and if there's a Condorcet winner, they will win. Like, is there a voting method that actually satisfies all of these fairness criteria? It turns out that there is not. So that's actually called Arrow's impossibility theorem, which basically says that it is not possible for a voting method to satisfy every fairness criteria that we have discussed. Now, of course, we're not going to go into like who this Arrow guy was or how he proved that, because that's pretty intense and beyond the scope of our class. But in and of itself, it's super interesting, right? The fact that you cannot create a voting method that satisfies all of the fairness criteria. And to me, I mean, if I sort of think about it loosely, that kind of makes sense, because, I mean, some things are like, I don't know, like the way you're counting. I don't know, this word arbitrary keeps popping in my mind. It's not that necessarily that it's arbitrary, but like, you're like, okay, we're going to assign points this way, right? So like when you decide a way to assign points, I can't see how that could possibly, just match up with all possible fairness criteria necessarily, right? Okay. So that's a really interesting thing to think about, right? The fact that it is not possible for one voting method to satisfy all the criteria that we've discussed, the 4 fairness criteria. All right, let's talk about what's called the Condorcet's voting paradox. So this is an interesting thing. So if we do, when you think about Condorcet, that should bring to mind pairwise comparisons. So if we do the pairwise comparisons of the options here, what do we got? 3 A, B, C. So we have A versus B, A versus C, and B versus C. Right? Okay. So how often is A preferred over B? Here and here. So that's 10. So we've got 10 to 5. How often is A preferred over C? We've got here. So that's 5 to, so A is preferred over C only 5 times. So C is preferred over A the other 10 times. All right, what about B versus C? How many times is B over C? Here and here. So that's 10. And then C is preferred 5 times. Okay. All right. So we can see, right, that if you look here, 10 people prefer A over B. 10 people prefer C over A, and 10 people prefer B over C. So it's interesting, these counts, like it's the same amount every time, right? So if we write it that way, if we say, like, and this is, I think, how the book puts it, right? 10 people prefer A to B, 10 people prefer B to C, and 10 people prefer C to A. These are the same words. So I thought I would wait to write them down. Okay. Okay, so 10 people prefer A over B, right? But 10 people prefer B over C. So you would think that maybe all 20 of those people prefer A over C, but that's not the case, right? So you can't, that property is, if that were the case, that's actually called a transitive property. You know, it's like, I don't know, like, I'm trying to think of an example of transitive. Equality is a really good example, right? Like if like a number A equals a number B, and then B equals C, then it must be the case that A equals C. So you've kind of like got this down the line transference. But that's not happening here, right? If A is preferred over B by 10 people and B is preferred over C, it's not the case then that A is preferred over C. So they're like saying here, like, no matter who you choose, right? 2/3 of the people would actually prefer somebody else, right? So they're like here, notice how there's no Condorcet candidate here. Like there's no one who wins in a pairwise comparison every time they're involved. All the numbers are equal, right? And so you would have to find some other way of finding a winner. But either way, whoever wins, if you look at pairwise comparisons, 2/3 of the people would prefer someone else. So that's interesting. Okay. And then after all this talk of voting methods and such, you may be wondering, well, like, how does voting happen in America, right? Or maybe some other country, you know, how does it work in other countries? Like, how do they, if there are elections and there is voting, how do they work? So in America, for most offices, there's a sequence of 2 public votes, right? Called the primary and then the general. Now, exactly how those work differs from state to state. And so it says here that typically the 2 candidates receiving the most votes will then move on in the primary, will then move on to the general. So that's kind of like a, there's sort of like a plurality thing going on there. They're like, okay, you had the most, and so you go on. I don't think there's no sort of like preference, like, or not preference, but ranking. There's no ranking going on where you say, okay, like here's my first choice, second choice, third case. That's not the case. If you've ever voted for, say, president, you see the ballot that you don't get to rank them. You're going to say, okay, I would like this person, but if you know, my second choice would be this person, and that's not taken into account. It's always just votes. So you can read what's here, and this is also in the book, right? It's kind of like instant runoff, but it's more like sequential, right? Because you do one election to sort of eliminate some people, and then you do another election to do things. And so here's some interesting information about primaries. Some states have closed primaries, right? Where you have to, like, you can only vote within your party. I believe California is like that. Like if you are a registered Democrat, then in the primary, you choose between the Democratic candidates, and then whichever one gets the most votes goes to be the Democratic candidate in the general election. Apparently, some states have an open primary, so you can pretty much vote for anybody you want. I kind of like that idea, because the thing about for California in a closed primary, say you're a registered independent, if there's no independent candidate running, then you have no say in any primary. You can't go and say, okay, you know what, since there's no independent candidate, I like, say, the Republican, or whoever you like. You might want to go and vote for them. You can't in if it's a closed primary. You're just out. So you have no say in who gets put up for those other parties if it's a closed primary. An open primary would take care of that. In other states, caucuses are used, and truly, I've never truly understood caucuses, but apparently they're basically just like meetings, right? But they're meetings of parties. So like you would have a Democratic caucus, right? And so all the Democrats would come together and they would talk. So it sounds to me like instead of doing just like necessarily just like a vote where you cast your ballot, you get together and you would do some discussion. I would assume that at some point there's some kind of vote in the caucus where you would say, okay, it sounds like from our discussion, we all like so-and-so. But I'm actually not sure because I've never taken part in a caucus. And apparently Washington State uses a different method altogether called a top two primary, in which voters select from the candidates from all the political parties, and the top two candidates, regardless of party affiliation, move to the general election. That's interesting. I've never lived in Washington State, so I've never experienced that myself, but that's an interesting idea. And then, of course, the general election is open to all people, and you can vote however you want. You don't have to be, if you're a registered Democrat, you could vote for the Republican candidate if you wanted, or vice versa. All right. So if you have any interesting, what's the word? I'm having trouble finding words lately. That's not good. If you have any interesting comments or anything to say, feel free to post in the forum anything you'd like to talk about or that you've read or heard. But that is our lecture for voting theory. Up next will be weighted voting. And remember to post questions in the forum if you have them. And I will talk to you later.